What's going on, everybody? Welcome to the 8th video of our linked list tutorial series. In this tutorial we are going to find the medial value of a linked list and return it. So we'll implement the bad way first, like as always, and after that we are going to write the optimal solution. So in here we have a linked list of 5 nodes, 1, 2, 3, 4 and 5, and we need to return the node value of the middle, so it will be 3 as an integer value. We need to return this. So if we didn't know anything about linked lists, I would assume a solution like this. First, we will traverse the linked list from 1 to 5. We are going to create a dummy integer variable and increment it 1 at every next traversal. And after that, we'll divide it by 2 and add 1 to it, since we want to find the middle value of it. And after that we are going to return the middle value, and we are going to assume that our linked list is an old value. For example, our length is 5 or 7, not some even value like 4 and 6. Otherwise we can't return the middle node of it because it will have 2 middle values. So let's try to implement it now. Let's call this int get middle, and this will have just one parameter, and it will be, oops, sorry guys, it will be a linked list node pointer head. So what we've talked about is we need to create a dummy integer variable. Let's call this count and set it to 0. And since we are going to traverse the head node twice, we need to create a dummy linked list variable, because we can traverse backwards, as you know. And linked list node pointer, let's call this, we can call it temporary actually, and it will be equal to head. Okay, so now we are going to traverse our linked list while our temp is not equal to null pointer, count plus plus, and temp will be equals to temp to next. So now we have counted all the nodes of a linked list, and now we can either use a for loop or anything you want. And as we talked about before, since our now temp variable is at the last node, we need to reverse it back to front, and it will just be as simple like this. Temp will be equals to head, and we can create a for or while loop, whichever you prefer here, but notice that you need to count from 0 to end of our count variable divided by 2 plus 1. The plus 1 is because since we have 5 nodes, 5 integer division by 2 will give us the answer of 2. We need to increment it by 1. Okay, that's it, actually it. But if you start from node 0, no, let's do it now. So it will go like this: for int I equals 0, I smaller than count divided by 2 plus 1, and I plus plus. And now our temp will be equal to temp to next. And after this for loop, we can just return temp's data here. So let's try it now. First, let's print our linked list, and after the print operation, let's call our get middle function and give the head node to it, and let's put a new line here. Actually, since we are starting from 0 and we are counting 0 as a number and we are incrementing it 1 by 1, this would be wrong. This plus 1 would be wrong, because in the zeroth operation we've traversed it once, so we need to delete it. It's my bad actually, sorry for that. So we are just going to count the number of total nodes divided by 2, create a simple for or while loop, whichever you prefer, then return the temp's data of it. So this is the simplest solution, and this is not the optimal solution. There's a better solution that works roughly in 35% or something like that better. So it will go like this. Let me write it first. Int get middle. Let's call this function optimal, since it will have the same parameters. We can't call the function name again, same. So it will have one parameter, linked list node pointer head, as before. And now we need to create 2 new nodes, and the new nodes will both be equal to head. After that I'll explain how we will do it. Let's call the first one slow, and let's call the other one fast. So it will go like this. Since we know that our linked list is an odd value, we are going to traverse the fast node with double the speed of it. So for example, we are traversing just one by one here, one step at a time. But in here, our slow node will be traversed by 1, but our fast node will be traversed by 2. So fast will complete the for loop in twice size, and slow will complete it the half of our fast node. Since it's just the half of our fast node, the speed is, it will give us the middle value at the end of our while loop. So it will go like this. While our fast is not equals to null pointer, we are just guaranteeing our solution here, since we are stepping with 2. And for example, if we stepped by 2 and now our fast node is null pointer, or we can't find the next of it, it will give a crash error. Therefore, we need to check if it's null pointer or not. And we need to write one more thing here, and that will be while our fast to next is not equal to null pointer, since we are going to traverse it twice at a time. So now it's just really easy. We are going to traverse our slow node just by 1. Slow will be equal to slow to next, and we are going to traverse our fast node by 2. And it will have a really similar explanation. Just write next twice. That's it. And after these operations, guys, our now slow node holds the value of the middle node, and we can just return the value of our slow node. Let's try it now. Get middle of head, but now we are going to call optimal. As you can see, now we have successfully regained 3 from our function. So what's the difference between them? Let's talk about it now. Let me zoom out a little bit. So in our first function, which we have told it's not optimal, we've traversed the full linked list, and the full linked list operation, which will take order of n time, and n is the length of linked list. Okay, and after this one, we are going to traverse it by order of n divided by 2 again, which will give actually a total solution of order of 3n over half time. But in this one, actually this is much faster, and not 35%, actually really much faster. Since we are traversing it 2 nodes at a time, this while loop, since we have 2 operations here, actually it will be a little bit slow, but not much. But this will roughly take n over half time. So as you can see, it's 3 times faster than this one, since we are traversing it once, and since we are traversing it 2 nodes at a time, we are just going to shrink our solution to half of our linked list size. So this is the optimal solution, guys. If someone asks you in an interview, be sure to write the solution, but you can prefer this one first and write this one after, so you will show your interviewer that you have full control over linked lists. So see you guys in the next tutorial. Bye.